Hello, hi everyone. Welcome to the next video of this one-shot series. In this video, we are going to discuss some previous year questions of chemical kinetics. I have divided all the problems into 8 topics, and in those 8 topics, we are going to discuss some different questions. Okay, so we are going to proceed in a systematic way. So first, we are going to discuss the weightage, syllabus, in terms of mind maps, and then we will solve some previous year questions or some important questions. So first of all, who will get benefit from this video? The point is that who knows the basics, who has the NCERT level knowledge, but when it comes to the JEE level questions, when it comes to the competitive type of question, they are unable to apply the concepts, they are unable to apply the formulas, right, while solving the questions. So this video is for those students. Okay, now let's talk about how to use this video. So first you have to revise the short notes. Even I will also provide some formulas related to the questions, right? But you have to revise short notes, you have to revise the complete chapter. Then you have to write down the important information. You have to write down all the important formulas with respect to this chapter, and then you can start solving the question. First, when it comes to the question, you have to solve on your own. If you are unable to get the answer, then you can see the solution for that, right? But the first task is that you have to apply your brain, you have to solve the question on your own. Okay, now let's discuss the weightage. So generally the weightage is going to be 4%, or we can say one question is going to be present in every set. But yes, in some sets we can have 2 or more questions from this topic. What are the high priority topics? So generally high priority topics, it's like order, calculation of order, and integrated rate equations. So we have integrated rate equations for different order of reactions. So you should know all those rate equations, and then you can easily solve the questions. Okay, now let's discuss the mind map. So first of all, chemical kinetics. In the chemical kinetics, first we are going to discuss the basics, right? So in the basics, we are going to discuss rate of a reaction, right? Rate of a reaction. So we have 2 types of rate of a reaction: average rate and instantaneous rate. Okay, then we have order. So in order, we have 0th order, first order, second order, nth order, right? Pseudo first order reaction. We have rate law. We can find out the order from the half-life, right? And we can have different plots with respect to the order of a reaction. We have reaction rate theory. In the reaction rate theory, we have activated complex theory, collision theory. We have the Arrhenius equation. In the Arrhenius equation, again we have the activation energy and the catalysis part. Okay, then there are some types of complex reactions in which we have equilibrium reactions, parallel reaction, sequential reaction, and catalysis. So we can have questions from these topics also. Okay, the last is a radioactive decay. So in the radioactive decay, which order is applicable, which law is applicable, we have to understand that part, and then we can simply solve the radioactive decay questions with the help of the integrated rate equation. That's it. Okay, so now as I have divided all the questions into 8 topics, so the first topic is the rate of a reaction, and in that we are going to discuss different questions by which we can solve the rate of a reaction. Okay, अब now if we have the generalized reaction, if we have what generalized reaction like A, B, B, it is in equilibrium with C, C or D, D, and whether it is in equilibrium or not in equilibrium, it means if we have this kind of reaction, so rate is going to be K. K is the rate constant. Concentration of A to the power X and concentration of B to the power Y. So this is called the rate equation. And now this X may or may not be equal to the coefficient of the reactant A, and Y may or may not be equal to the coefficient of the reactant B. If we add the coefficients, yani not coefficients, if we add the power of concentration of A and B, that is X plus Y, then we can find out the order of the reaction. Okay, so for a particular reaction, we have the rate law, or we can say what is rate? Rate is the change in concentration per unit time, and on the basis of that, what is the unit of rate? That is the mole per liter per second. ठीक है. अब now if we have this reaction, then how we can find out the rate, right? So rate क्या होगा, 1 by a minus dA by dt is equal to 1 by v minus dB by dt is equal to 1 by c dc by dt is equal to 1 by d dt by dt, right? So minus dA by dt, it is actually the rate of disappearance of the reactant A. Minus dB by dt is the rate of disappearance of the reactant B. dC by dt is the rate of appearance of the product C. d by dt is the rate of appearance of product D with respect to time. Okay, now we have two types of rate now, average rate and instantaneous rate. So how to calculate average rate? When the time interval is too much, like if you want to find out the rate after 10 minutes, 20 minutes or whatever, right? So when we have the appreciable time range, then we are going to calculate average rate, and average rate is what? Final concentration minus initial concentration divided by the change in time. Okay, now instantaneous rate we are going to calculate when the time is very small or time interval is very less. So rate is going to be minus dA by dt if we talk with respect to the reactant A. So we can find out the rate with respect to reactant A, reactant B, product C, product D. So we can easily find it out. Okay. Okay. Now let's start solving the question number 1. So question number 1 says, for the reaction 2A plus 3B plus 3 by 2C gives 3P. So which statement is correct? So if you see the options carefully, it means we have to find out we need to write down the rate now. We need to write down the rate. So see, 2A plus 3B plus 3 by 2C. So how to write rate? Right, so that is going to be 1 by 2. Either we can write change in concentration of A, or we can say number of moles of A. ठीक है, तो dNA by dt is equal to 1 by 3 dNB by dt, and that is equal to 1 by 3 by 2 dNC by dt. So on solving this further, we get 1 by 2 dNA by dt, it is equal to 1 by 3 dNB by dt is equal to 2 by 3 dNC by dt. Okay, now if you see the option dNA by dt coefficient, it is actually 1. So it means I am going to multiply this with 2. So on multiplying the above equation with 2, we get dNA by dt is equal to 2 by 3 dNB by dt, which is equal to 4 by 3 dNC by dt. ठीक है? So the answer is going to be option number 3. Option number 3 is going to be the answer. So this is the simple thing, simple question, right? Now for certain chemical reaction X to Y, the rate of formation of product is plotted against the time as shown in the figure. The number of correct statement from the following is. So rate versus time curve. So we have discussed this part in equilibrium also. So if I'm going to plot, right, rate versus time, then what happens? Basically with time, rate of formation of product, right, it increases, and after some time it becomes constant. It means at this point equilibrium is achieved, right? We can say at this point equilibrium is achieved. So option A or statement A, overall order of the reaction is 1. No, we cannot predict the order. From rate versus time, we cannot predict the order, right? So concentration change should be there. We can predict the order if we have the concentration change with respect to rate change. Then we can find out the order, we can predict the order. How? For example, if concentration change, it is 2 times, right? Or 3 times, or we can say n times. Okay, and rate change, no change in rate, है ना? Rate change, no change. So order with respect to this is going to be 1. But we cannot find out the order with the help of the rate versus time curve. Okay, so it means this statement is incorrect. Order of the reaction can be determined. This is true. In region 1 and 3, the reaction is of, no, we cannot predict order, so no. In region 2, the reaction is of first order, no. No, right? So it means the number of correct statement from the following is 1. Answer is 1. Okay, so from rate versus time, we cannot predict the order. Okay, now let's do next question. So next question, in the reaction of formation of sulfur trioxide by contact process, and the process is this 2SO2 gas plus O2, it is in equilibrium with 2SO3. Okay, so the rate of reaction was measured as dO2 by dt is this, the rate of reaction in terms of SO2. Okay, so if I'm going to write down the rate of reaction, so that is going to be half minus d SO2 concentration by dt is equal to 1 by 1, because coefficient of oxygen is 1. Here coefficient of SO2 is 2. So we can write 1, and that is dO2 by dt. Okay, bete. So now we have to find out minus dSO2 by dt, which is equal to 2 into dO2 by dt, it is given minus 2.5 into 10 to the power minus 4. So on solving, what do we get? We get minus 5 into 10 to the power minus 4 mole per liter per second. Okay, mole per liter per second. So answer is going to be fourth. Option 4 is the correct answer. Let's do next question. A plus 2B gives C. The rate equation for this reaction is given as this. Okay, so rate equation is K A ka power 1 and B ka power 1. So question says if the concentration of A is kept the same and B is doubled, then what will happen to the rate itself? So I am taking this as R1. So R2 is going to be K. A concentration is same, but B 2B. Okay. So if I say R2 by R1, so R2 by R1 it is going to be K R2 by R1, it is equal to K A 2B, or we can say that KAB. So R2 it becomes 2 times of R1, right? So the rate of reaction is doubled. Answer is 3. Rate of reaction is doubled. Now let's do next question. In the following reaction, XA it gives YB. Okay, A and B respectively can be. So see how to write down the rate law for this one. I can write 1 by X minus dA concentration change by dt, it is equal to 1 by V Y plus dB by dt. Okay, so we can say minus dA by dt, it is equal to X upon Y dB by dt, right or wrong? Now let's take log, taking log both sides, taking log both sides. So on taking log both sides, we get minus, or we can say log minus dA by dt, it is equal to log x plus y plus log dB by dt, right? ठीक है? Now, if I compare this equation with this equation, so we can say 0.3010, it is equal to log x by y. So let's write this. Log x upon y is equal to 0.3010. So we know that 0.3010 is the value of log 2. So we can compare x upon y, it is equal to 2, or x is equal to 2 times of y. Right. So we have what? XA gives YB. So it means coefficient, this x is 2y. Right. So it means now we have to compare or prove this thing from the options. So if you see option number this, third, C2H4 and C4H8. So if A is C2H4 and this is C4H8. So this is 2 times, na? 2 times of C2H4, it is equal to C4H8. It means that is going to be the correct option. Okay? If y is equal to 1, then 2y is equal to 2. So from that, option number 3 is the correct option. Okay. Now let's do next question. For a reaction scheme A, K1 gives B, K2 C. Okay. Now rate of formation of B is set to be 0. It means B ka rate is going to be 0. It means dP by dt it is equal to 0. Okay. Okay, fine. Then the concentration of B is given by. So how to find out B? So see, from this, what we can write dB by dt, it is equal to K1 concentration of A, right? Here it is the rate of formation of B. But in this step, there is the disappearance of B. So what we can write? We can write minus K2 change in concentration of B. So dB by dt is 0. So we can say K1A minus K2B, or we can say that K2B it is equal to K1A. So from here concentration of B it is equal to K1 upon K2 concentration of A. Okay. So option 4 is the correct answer. Okay. Now let's do the next question. For an elementary chemical reaction, what are elementary reactions that occurs in single step? A2 gives 2A, K1 upon K minus 1. So the expression for dA over dt is dA over dt is. So how to write this? So देखो, we can say 1 by 2 dA over dt, it is equal to K1 A2 and minus K minus 1 A ka power 2. Because for the backward reaction, there is a rate of disappearance of this. And for the forward reaction, we get A, or we can say rate of appearance of A. So here we write positive and here we write negative. Understood? Now, if I write dA over dt, so it becomes 2K1A2 minus 2K minus 1 A square. So from this, option 4 is the correct answer. Okay. Now, let's discuss next type of the problem, and in this topic we are going to discuss questions related to the order of the reaction. So how to find out the order? So if we have any rate law expression, if we have rate law expression as this, rate law expression as this, then x plus y is going to be the order of the reaction. Order is the experimental value. It is the experimental value. It is not a theoretical value. So order can be in fractions, right? So fractions हो सकते हैं, normal मतलब we can have order 1, 0, 3. It can be in fraction also. ठीक है, we can also predict from change in concentration and rate. So what? See, if the concentration changes 2 times, 3 times and n times, right, and there is no change in the rate, then the order is going to be 0. If concentration change of any reactant or any substance, right, it is 2 times, 3 times and n times, and rate changes also 2 times, 3 times or n times, then the order is going to be 1. Okay. If concentration changes 2 times, 3 times or n times, and rate is n square times, right? So if concentration, there is a change in concentration 2 times, but rate changes 4 times. If there is a concentration change 3 times, but the rate changes 9 times, then the order is going to be 2. So n square times hoga, order is 2. If we have concentration change n times and the rate change n cube times, then the order is going to be 3. Then the order is going to be 3. Okay. So what we can do, we can also find out the order with respect to the half-life. So if half-life is given, then we can also predict the order of the reaction. Like T half, it is directly proportional to the concentration change to the power 1 minus n, where n is going to be the order of the reaction. N is going to be the order of the reaction. So from this formula, we can predict the order of the reaction. Okay, that's it. Now let's start solving the question number 1. So let's solve question number 1. For a chemical reaction A plus B gives product, the order is 1 with respect to A and B. So what is the value of x and y, right? So what is the value of x and y? So how to solve this question? So the question says like if I write the rate is k a to the power 1 and b to the power 1, because order with respect to a is 1 and order with respect to b is also 1. Okay, so that's how we can write down the rate law expression. Now, what is the value of x and y? So, how to solve this? So, suppose this is R1 and this is R2. So, what I am going to do, I can take R1 upon R2. So, R1 upon R2, say I can write K upon K, concentration of A to the power 1, concentration of X to the power 1, here zero point 0.5 to the power 1 divided by zero point 0.5 to the power 1. So, cancel R1 and R2, it is equal to 0.10 upon 0.40. So we can write 20 by x is equal to 1 by 4. So value of x is going to be 20 into 4, that is equal to 80. Okay, so the value of x is 80. Similarly, if we solve for R1 and R3, right? Solve R1 and R3. So we can get the value of y. So let's solve R1 and R3. So R1 and R3, that is equal to 0.10 upon 0.80. That is K upon K. Concentration of A over here 20 upon 40. So this is 20 upon 40 to the power 1, because order with respect to A is 1. And then we have 0.5 over y, 0.5 over y, and that is 1. So we get 1 by 8, it is equal to 1 by 2 into 5 by 10 y. Okay, so y is equal to 5 into 8 upon 2 into 10. So on solving, what do we get? 5 ones are 5 twos are, and 2 fours are 2 twos are. So y ka value is 2. Okay, y ka value is 2. So it means the answer is going to be 3. Answer is 3, 80 and 2. Now let's solve question number 2 for this time. So the reaction of 2NO plus Br2 gives 2NOBr takes place through the mechanism given below. So mechanism is this. The first step is this and second step is this. So the rate determining step is the slowest step. Okay. Rate determining step is the slowest step. Slowest step. So rate we can write from the second reaction, from this reaction. So rate is K NOBr2 and NO. Okay. Now, if you see the actual reaction, NOBr2 is not in this reaction, right? NaBr2 is not in this reaction. So it means we have to convert, we have to find concentration of NOBr2. So concentration of NOBr2 we can find from first step, because first step is the equilibrium step. Okay, so first step is what? NO plus Br2, it is in equilibrium with NOBr2. That's the first step and that is the equilibrium step. So K equilibrium we can write NOBr2 upon NO and Br2. Okay, so from this NOBr2 concentration is going to be K equilibrium concentration of NO and concentration of Br2. So this is second and this is equation number 1. So put second in 1. So on putting second in one equation, so we get rate is equal to K equilibrium NO Br2 and NO. Okay, why? Because in place of NOBr2, right, I have written K equilibrium NO concentration, Br2 concentration. So on the basis of that we get K, suppose this is K dash, then we get NO to the power 2 and Br to the power 1. So if I want to find out order, so order is going to be 2 plus 1, that is equal to 3. Okay, so order of reaction is, answer, it is 3. Okay, now let's do next question. For the reaction 2A plus B, it gives C. The values of initial rate at different reactant concentration are given in the table below. So the rate law for the reaction is, so we have to find out rate law. So for the rate law is what? K, A to the power X and B to the power Y. It means we have to find out the order with respect to this reaction. We have to find out the value of X and Y. So how to solve this? Suppose this is R1, this is R2 and this is R3. Okay, so first we are going to that term or that equation in which one concentration is constant or concentration of any one of the reactant is constant. So if we see 1 and 2, so here concentration of B is constant. So R1 upon R2, R1 upon R2, that is going to be 0.05 upon 0.090. Okay, that is K. Concentration of A is 0.05x and B is 0.05y divided by K, so that is 0.10x and 0.05y. So on solving, what do we get? We get 45 upon 90, which is equal to 5, right? That is equal to 5. ये होगा ना 5 upon 10 का power x. ठीक है? So this is equal to 45 to the 90, 1 by 2, 1 by 2x. So on comparing this, x का value is going to be 1 or order with respect to a is 1. ठीक है? Now similarly we have to find out value of y. So for value of y, I am going to take that one in which concentration of A is constant, but here we do not have any such thing. So I can take what? We can take R2 and R3 because in R2 and R3 concentration of B is different. ठीक है? So on solving R2 and R3, so what is R2? 0.090, 0.090, then 0.72 बेटे, ठीक है? 0.72, then K 0.10x and 0.20y. Here y 0.05y and 0.10y. ठीक है? So we have to solve this. So for this we can write 90 upon 720. K से K we can cancel out. We can cancel out K to K. Then we have what? 1 by 2, 1 by 2x and x का value is 1. So it means 1 by 2 का power 1 and here we can write 5 by 10 का power y. ठीक है? So 90 upon 720 which is equal to 5 by 20 y or 90 upon 720 which is equal to 1 by 4 y. 1 by 4 y. ठीक है? Clear? So if you solve this, so what do you get? So 90 upon 720 ko what we can write? We can write this as 1 by 8 is equal to 1 by 4y. Now how to solve this? We can say 1 by 2 and that is 1 by 4. That is equal to 1 by 4y. Right? 1 by 4y or 1 by 4y or not 1 by 4y. We can not write this as 5 by 20y. Let me correct this part. This is going to be 90 by 720. This is 1 by 2 1 and that is 1 by 2 y. ठीक है? So what we can write 90 upon 720 that is going to be 1 by 2 and 1 by 4. Okay, so that is 1 by 2 1 and 1 by 2 y. So if I compare this, so this is 1 by 2 and 1 by 2 ka power 2. That is 1 by 2 1 and 1 by 2 ka power y. So from this y value comes out to be 2 on comparison, right? Y value comes out to be 2 on comparison. So it means the order with respect to B is 2 and answer is 4th. ठीक है? Order with respect to B is 2 and the answer is 4th. Now let's do next question. So next question says a student has studied the decomposition of gas AB3 at 25 degrees Celsius and he obtained the following data. ठीक है, so from here we have to apply the order, or we are going to find out the order with respect to T half, because in the question we have T half, it is given in the question, right? So we know that T naught hai, so that is directly proportional to A naught 1 minus N, but here pressure is given, so we can say that T half is directly proportional to P naught 1 minus N. ठीक है, so let's solve for this one. T half 1 upon T half 2, that is equal to P naught 1 minus N upon P naught 1 minus N. ठीक है, so I am taking this as 1 and this as 2. So on solving this further, we get 4 upon 2, which is equal to 100 upon 50 1 minus N, so which is equal to 2, and that is 2 1 minus N. ठीक है, so from this what we can write, 1 minus N is equal to 1 and the value of N is equal to 1 plus 1 equal to 2. ठीक है, so the order of the reaction that is equal to 2, so answer is option number 2. Okay, now let's do next question. Initial rates of the A plus B gives P, okay, at different initial concentration of A and B, they are given below and we have to write down the rate equation. So how to write down the rate equation over here? So we have to use the initial rate method in order to find out the order, because rate is equal to k a का power x and b का power y. ठीक है, तो first task is to find out the value of x and y. ठीक है, so first what I'm going to do, let's take where b is constant, b का concentration is constant. So suppose this is r1 and this is r2. Now let's solve for r1 and r2. So when we solve for r1 and r2, so this is going to be 0.05 upon 0.10, k upon k. Concentration of A is 0.1 to the power x, this is 0.2 to the power x, this is 0.1 to the power y and 0.1 to the power y. So cancel, cancel. So here we get 5 by 10 and this here we get 1 by 2 x. So we can say 1 by 2 is equal to 1 by 2x. From this x is equal to 1. So order with respect to A, it is equal to 1. Similarly, we are going to solve for V. So we are going to take that rate where concentration of A is constant, like C, R1 and R3. ठीक है, so let's take R1 and R3. So R1 and R3, so value of R1 and R3, it is equal to 0.05, 0.05, 0.05 and 0.05. Okay, so K, concentration of A is constant, 0.1, 0.1. So we can say 0.1x upon 0.1x. Now concentration of Y, 0.1 and 0.2. So write 0.1 y and 0.2 y. So cancel, cancel, cancel. So this is 1 and this is 1 by 2 ka power y. So for this, what we can write, 1 by 2 the power 0, it is equal to 1 by 2 power y, right? So y ka value is 0. So order with respect to B is 0. Order with respect to B is 0. So how to write down the rate equation? So rate equation is R is equal to K A, because B का power is 0, which is equivalent to 1. Now our task is to find out the rate constant of the reaction. So how to find out the rate constant of the reaction? So for rate constant, R is equal to Ka. So let us take any reaction. Let me take R1. So Ka. So R1 0.05, 0.05 K. Concentration of A is 0.1 over here. So 0.1. So K is what? 5 into 10 to the power minus 2 and this is 1 into 10 to the power minus 1, right? So on solving, what do we get? 10 to the power minus 10 to the power minus 1 cancel out, so we get 0.5. So the rate constant value is going to be 0.5. Clear? That's it. Okay, that's it. So rate constant value is 0.5. Okay. Now let's do next question. So next question, for the reaction 2A plus B gives product. When the concentration of A and B both were doubled, the rate of the reaction increased from 0.3 to 2.4 mole per liter per second. Okay, fine. So first what we are going to say कि देखो R1 is K a to the power, it's not a to the, हाँ ठीक है, a to the power x and b to the power y, ठीक है. अब now for this rate is 0.3 mole per liter. अब question says when the concentration of a and b both were doubled, so it means this is 2a to the power x and 2b to the power y. So it means concentrate मतलब rate increases from 0.3 to 2.4. ठीक है. अब now next, that is the for that these are the equations that we can derive from the two sentence. ठीक है. Now next part. When the concentration of A alone is doubled, the rate increases from 0.3 to 0.6 mole per liter. When concentration of A alone is doubled, so R1 is this, so R3 क्या होगा, K 2AX and B as it is. So rate increases from 0.3 to 0.6. So देखो, in order to calculate X, what we can do, R1 upon R3. So let's do R1 upon R3. So R1 upon R3 is 0.3 upon 0.6, right? So K. Concentration of A is doubled, so we can say 1 by 2 to the power x, and concentration of B is same in this 1 and 3, concentration of B is same. ठीक है, तो we can say that 1 by 2 is equal to 1 by 2x, so x का value is going to be 1. So order with respect to A it is equal to 1. ठीक है, so order with respect to A it is equal to 1. Now in order to calculate B का amount, what we can do, R1 upon R2. ठीक है, so let's say R1 upon R2, let's take R1 upon R2 which is equal to 0.3 upon 2.4. 0.3 upon 2.4, तो K upon K, तो A upon 2A, ठीक है, fine. A X 2A X B X 2B Y, sorry, Y. Order with respect to B is Y. So what we can say that, so that is going to be 3 by 24. So 3 by 24 को what we can write, ठीक है, 3 by 24 को we can write as 1 by 8. So that is x का value is 1. So we get 1 by 2, and here what we can write, 1 by 2 का value y. So from here on solving we get y का value as 2. So order with respect to B is 2. So this is the correct answer. Okay. Now let's do the next question. 2NO plus Cl2 gives 2NOCl. The reaction was studied at minus 10 degrees Celsius. Okay, fine. What we are going to do? Again, we have to find out the order of the reaction. So how to do the order of the reaction? So similarly, you have to take R1. Here you have to take R2 and R3. So first you can take R1 and R2. When you take R1 and R2 का value, then you can get the value of Y, right? You get the value of Y. And when you take R2 by R3, then you get the value of X. So when you get the value of X and Y, so the order is going to be the X plus Y. And rate is what? K NO to the power X and Cl to the power Y. So when you solve this completely, you get the order equal to 3. So that is the answer. Please try this at home. You can easily solve this question, right? You can easily solve this question. Next. Okay, fine. We have already discussed this type of question, right? So you have to find out first order. R is what? K. A to the power 2. A to the power 2. B to the power Y. A to the power X and B to the power Y. Right, so first you have to find out order with respect to A and B. It means you have to find out the value of X and Y, right? Or here X and Y is this now. So you can also say that this is P and this is Q. Okay, so first you have to find out the value for P and Q, and then you can find out the value of X and Y. So when you solve this, you get answer 3. So please try this at home. ठीक है? Try this at home. Now let's do next type of question. Okay. So the given plots represents the variation of concentration of reactant R with time for two different reactions, 1 and 2, the respective order of the reaction. So to this type of question, we have to take help from the integrated rate equation, है ना? We have to take help from the integrated rate equation. So for zero order, we have zero order. So zero order reaction is initial concentration minus final concentration of reactant is equal to Kt. So if I want to plot in between A and time, right? Or we can also transform this equation as R naught minus R is Kt. So R is going to be R naught minus Kt. Now if you compare this equation with y is equal to mx plus c, so m is equal to minus k, यानी slope is minus k, ठीक है, and we have intercept equal to r naught. So straight line equation if we have to follow, then this second one is the zero order reaction. This is zero order reaction. Up now in the first one there is a plot in between ln r and time. So integrated rate equation with respect to integrated rate equation for first order. So for first order, what is the integrated rate equation for first order? K is equal to 1 by T ln initial concentration of the reactant upon final concentration. So if I am going to solve this completely, so I get Kt ln R naught minus ln R. So ln R is equal to ln R naught minus Kt. So this is Y, then C, or this is mx. Again slope is minus k, negative slope, and intercept value is equal to ln R naught. Right? So it means this equation is for first order reaction. So answer is 1 and 0. Option number 1 is the correct answer. Okay. Now let's do next type of question. ठीक है. So log rate versus log concentration. Log rate versus log concentration we have to plot. ठीक है. What? Log rate and log concentration. Fine. So the order of the above reaction. So how to solve this? So see देखो. Rate is equal to K A to the power 0 if the reaction is zero order. So R is equal to K. So log R is equal to log K. यानी zero order reaction is independent on the concentration, right? Zero order reaction is independent. So यहाँ तो कुछ भी नहीं है, nothing is true for that. Now if we have first order, तो R is equal to K concentration to the power 1. So log R is what? Log K plus 1 log A. ठीक है, so this is Y, this is C, and this is mx. If we have second order reaction, so K A to the power 2. So it means log R log K plus 2 log A. So Y is equal to C plus mx. So here slope is 2. Here slope value is 1. It means the one which has more slope, that is going to have more order. ठीक है, तो if you see the curves properly, so which one has more slope? So the fourth one is going to have more slope. Then slope is for second one, then that is for first one, and that is for again third one. So that is the order of slope. ठीक है, so from the order of slope we can find out the order of the reaction. The curve which has maximum slope, that is going to have maximum order. So as per this, option number 4 is going to be the correct answer. Okay, fine. Now we are moving to the next type of the question, which is related to the integrated rate of equation. So basically in the integrated rate, we have certain reactions which involves rate constant K, time, and the concentration of the reactant, initial concentration of the reactant and final concentration of the reaction. So on the basis of that reactions, we have certain questions. So let me write down some formulas, or let me discuss some of the formulas which we are going to use in this type of questions. So for the zero order, we have Kt is equal to initial concentration of the reactant minus final concentration. Okay. this one, T half A naught upon 2K and T completion A naught by K. Okay, so A naught initial concentration, A is going to be the final concentration. For the first order reaction, it is A is equal to A naught e to the power minus KT. Then KT is equal to 2.303 log A naught upon A, initial concentration upon final concentration of the reactant. T half is equal to 0.693 K and T completion is infinite. It means first order reaction takes infinite time to get complete. Now we have the second order reaction. So for that, 1 by final concentration minus 1 by initial concentration is equal to KT and the T half is equal to 1 by K A naught. For nth order reaction, if you have any nth order reactions, so you can use this formula. But that is not applicable for the first order reaction. It is only applicable for other order of the reaction, right? Now we have certain other formulas. If the volume is given, pressure is given, infinite volume is given in the question, yeah, infinite pressure is given, or specific rotation, right? Optical rotation method, right? If they are given now, so we can use this formula. 2.303 upon T log V infinity minus Vt, then 2.303 upon T log V infinity minus V naught upon V infinity minus Vt. So we have certain formulas for that. Okay. Up now we have one more thing. If I'm going to relate the order of the reaction with the half-life. So if we have the zero order reaction, so starting with suppose we have 100. So half-life, it means concentration is reduced to half. So if it happens in 10 seconds, then successive half-life, it takes less time to get complete. ठीक है, तो 25 to 12.5, तो again 5 का half, that is 2.5 seconds. Okay, first order reaction, तो first order reaction में T half is going to same. So 100 to 50, it happens in 10 seconds, 50 to 25, it happens in 10 seconds, 25 to 12.5, it happens in 10 seconds. For the second order reaction, successive half-life time, it increases. So 100 to 50, if it happens in 10 seconds, then 50 to 25, it happens in 20 seconds. And then 25 to 12.5, it happens in 40 seconds, right? So 25 to 12.5, it happens in 40 seconds. So that's how we can relate T half with the order of the reaction. And for that, we have the formula. T half is directly proportional to A naught 1 minus N. So now let's discuss the question number 1. A molecule undergoes two independent first order reactions whose respective half-lives are 12 minutes and 3 minutes. If both the reactions are occurring, then the time taken for the 50% consumption of the reactant in minute, right? So how to solve this question? So T half 1, it is 12 minutes, that's the first order reaction, and T half 2, that is equal to 3 minutes, right? And that is for first order reaction but different reaction, right? Because we have two independent first order reactions. So how to solve this question? So question says if both the reactions they are occurring, then the time taken for 50% consumption of the reactant in minute is. So देखो, we know that T half formula is what? 0.693 upon K. So here we can write. So from here we can find out T half 1, it is equal to 0.693 upon K1. 0.693 upon K1. Now 0.693 upon K1. So what we can write after that? Like T half 1, that is equal to ln2 upon K1. Similarly for the second one, we can write T half 2, it is equal to ln2 upon K2. ln2 upon K2. Okay, fine. Is it clear? We can write this thing. Up now, if we see the formula, then T half and rate constant, they are reciprocal, right? They are opposite, right? So basically what we can say that K and T are are inversely proportional, right? K and T, they are inversely proportional. So we can say that 1 by T total is equal to 1 by T1 plus 1 by T2. ठीक है, तो 1 by T1 is 1 by 12 and then 1 by 3. So on solving this, we get 4 right? 4 plus 1 upon 12, which is equal to 5 by 12. So T total, it is equal to 12 upon 5, which is equal to 2.4 minute. Okay, which is equal to 2.4 minute. So if I want to report this in nearest integer, so I am going to write as 2. I am going to write as 2 as the answer. Is it clear? Okay. Now let's do next question. So the number of incorrect statement from the following is: the successive half-lives of zero order reaction decreases with time. Yes, we have already discussed, right? So T half is what? That is A naught upon 2K, right? So uh, basically, successive half-lives of zero order reaction decreases with time. That is going to decrease. Yes, it is true. It is true. So how we can say that? Because on increasing time, concentration of A naught जो होगा, that is the initial concentration है ना, initial concentration पे final concentration पे तो dependent ही नहीं है. Clear? So A naught value decreases ना, A naught value decreases with the time. Starting में 100 है, then it is 50, then it is 25. So A naught value decreases. So if A naught value decreases, so we can say that T half is directly proportional to A naught. So half-life also decreases. So the first statement is true. Now the second one, a substance appearing as reactant in a chemical equation may not affect the rate of a reaction. A substance appearing as reactant in the chemical equation may not affect the rate of a reaction. Yes, it is true. If the order with respect to that reactant is 0, if the order with respect to that reactant is 0, so suppose we have A plus B and it gives product. So if I write rate, the rate is K, A का concentration to the power x and B का concentration to the power y. So I am saying कि suppose let y is equal to 0. So if y is equal to 0, then rate becomes independent to the concentration of B. ठीक है, independent to the concentration of B. So this statement is also true. Now second, order and molecularity of a chemical reaction can be a fractional number. See, this statement is false. Why? Why C is false? Order is the experimental, right? Order is experimental while molecularity is theoretical. It is the theoretical. So molecularity cannot be fractional. Cannot be fractional. So that is false. Now let's understand the statement number D. So statement number D, the rate constant units of zero and second order reaction are this. Okay, fine. So rate constant unit, how to solve rate constant unit? So rate constant unit is bete mole per liter 1 minus n s second inverse, where n is the order. Where n is the order. So for zero order, value of K is, or unit of K is mole per liter second inverse. And for which order? Second order. So second order, for second order, so value of K is mole minus 1 liter second inverse. ठीक है, mole minus 1 liter second inverse. So it says mole per liter per second, right? And mole minus 1, this is true. Okay, this is true. So number of incorrect statement from the following. So only one statement is incorrect. Answer, only one statement is incorrect. Only one statement is incorrect. So we have option number C as the answer. Okay. Now let's do next type question or next question. So we have KClO3 plus 6 FeSO4 plus this. This is the equation. The question says the above reaction was studied at 300 Kelvin by monitoring the concentration of FeSO4, in which initial concentration was 10 molar and half an hour it becomes 8.8 molar. So the rate of production of this. So FeSO4 concentration is given, right? So what we can do, we can find out the rate with respect to FeSO4. We can find out the rate with respect to FeSO4. So see how to find out. So delta FeSO4, right? Delta FeSO4 upon delta T. So here we can write down 8.8 minus 10 upon delta T, half an hour means 30 minutes, and we have to report answer in seconds. So 30 minutes is equal to 30 into 60. So 1800 seconds. So we can say 1800 minus 0. So we get answer equal to something minus 6.66 into 10 to the power minus 4. ठीक है, this is the rate with respect to FeSO4. Now what I'm going to do, I'm going to relate FeSO4 and Fe2SO4 whole thrice. So it means what we can say, 1 by 6 minus delta of FeSO4 upon delta T is equal to 1 by 3 delta of Fe2SO4 whole thrice upon delta T. ठीक है, this we can write. So delta Fe2SO4 whole thrice upon delta T, that's what we need to find out. So that is equal to 3 by 6 into 1.66 into 10 to the power minus 4, which is 1.66 upon 2 into 10 to the power minus 4, which we can write as, क्या लिख सकते हैं हम इसे? So we can write as 3.33 into 10 to the power minus 4. We have to report the answer in terms of 10 to the power minus 6. So this is 333 into 10 to the power minus 6, right? 333 into 10 to the power minus 6. So the answer is 333. Clear? The answer is 333. Let's do next question. So T87.5 is the time required for the reaction to undergo 87.5% completion, and T50 is the time required for the reaction to undergo 50% completion. So the relationship between T87.5 and T50 for a first order reaction is. So basically, how to solve this? So see, T87.5, T87.5, it is 1 by K ln initial concentration 100, and final concentration is going to be for 87.5. The final concentration is 100 minus 87.5. So 100 minus 87.5, it is equal to 12.5. So this is 87.5. ठीक है. अब now we have what, 50% completion. So 50% completion यानी T50 for first order reaction, it is 0.693 upon K, right? And fine. So we can write K is equal to 0.693 upon T50, right? So I am going to put equation number 2 in equation 1. Okay? So on putting equation 2 in 1, putting 2 in 1. So what do we get? We get T87.5, K is equal to, we can say K क्या हो जाएगा? What is the value of K? So 0.693 upon T50. So this is T50 upon 0.693, and this is ln 100 upon 12.5. ठीक है, ln 100 upon 12.5. So when we solve this, so we get T87.5, it is T50 upon 0.693, so ln 1000 upon 125, right? So on solving this, so this is 25 5 is a 125, 25 4 is a 100, 5 is a 5 8 is a, ठीक है. So T87.5 is equal to T50 0.693, I can write as ln 2, and that is ln 2 का power 3, है ना, ln 2 का power 3. So on solving it further, what do we get? We get T87.5, it is equal to T50 upon ln 2, 3 ln 2, so ln 2 cancel. So T87.5 is 3 times of T50. So x का value is 3, right? X का value is 3. So answer is 3. Clear? Now let's do next question. So next question says A gas, it gives 2B gas and C gas, it's a first order reaction. So the initial pressure of the system, it was found to be 800 mm of Hg. So initial pressure 800. So starting में products का we do not have any pressure. So this is 800, which increased to 600 mm Hg after 10 minutes. यानी after 10 minutes it increases to 600. So we can say 800 minus P naught. This is 2 P naught and this is P naught. So 800 minus 2, 800 minus P naught plus 2 P naught plus P naught, it is equal to 1600. So we can say that 800 plus 2 P naught is equal to 1600. So 2 P naught is equal to 800 and P naught value it is equal to 400. ठीक है, that is after 10 minutes. So the question says the total pressure of the system after 30 minutes will be. So after 30 minutes, so just try to understand over here. Here pressure is 800 and now we have 800 minus 400, so it is 400. So pressure reduced to half, pressure is reduced to half for this A. So we can say that ki T10 is the T half, and if it is, and we know that this is the first order reaction, so we can say 0.693 upon K, right? So K value is what? 0.693 upon 10, which is 0.0693. Up now question says the total pressure of the system after 30 minutes. So how to solve this? So we know that now K is equal to 2.303 T log initial pressure 800 and final pressure we have to find out, है ना? We have to find out the final pressure. So suppose that final pressure is P dash, or we can say P naught dash. ठीक है? So how to solve this? How to solve this? How to solve this? So K को we can write as 0.0693 and this is 2.303 upon 30 and this is log 800, और ये भी लिख सकते हैं what we can write final को, that is 800 minus P naught dash. So that is 800 minus P naught dash. So on solving this now, on solving this completely, you get value equal to 800 upon 800 minus P naught dash as 8. ठीक है, P naught dash is 8. So after solving this further, we get P naught dash is equal to 700. We have to find out the total pressure, right? So total pressure is what? 800 plus 2P naught. 800 plus 2P naught. So it means total pressure is 800 plus 2P naught, which is equal to 800 plus 2 into 700. On solving this further, you get answer equal to 2200. 2200. So that is going to be the answer. Okay. So that is going to be the answer. The answer is 2200. Okay, now let's solve next question. For the first order reaction A to B, right? The half life is 30 milliminutes है. I guess this is 30 milliminutes. ठीक है, तो half life is this. The T half is equal to 0.693 upon K and the value of K is 0.693 upon 30. Okay, बेटे. So the time taken for 75% completion. So 75% completion means if A naught is equal to 100, then A is 100 minus 75 of 100 ना. So 75 complete हो गया, तो it means we get 25. So how to solve this? So we know that T is equal to, we have to find out time taken. Okay, T is equal to 1 by K और ln 100 upon 25. ठीक है, so K को we can write as 0.693 upon 30, so it means 30 upon 0.693 and that is ln 4. So 30 0.693 को I can write ln 2 and this is 2 ln 2. So ln 2 cancel, so answer is 60. 60. ठीक है, so that is the answer. Okay, now let's do next question. A first order reaction has a rate constant K is this. Okay, K is this 4.6 into 10 to the power minus 3 second inverse. Perfect. So we have to find out the number of correct statements from the following, right? So reaction completes in 1000 seconds. Array, for first order reaction, what happens? T completion is infinity, है ना, already discussed above. T completion is infinity. T completion is infinity, so we cannot complete this. So this is incorrect. That is false. Now, second, the reaction has a half-life of 500 seconds. So half-life of 500 seconds, how to calculate? So for B1, we know that T half is equal to 0.693 upon K. So K is 0.693, K is 4.6 into 10 to the power minus 3. On solving this, you get 150.6. Itna. So basically, again, that is not true. So this statement is also false. Now let's solve for the third one. The time required for 10% completion is 25 times the time required for 90% completion. It means T 10% कितना है? X of T 25. So we have to find out the value of X, which is T 10% upon T 25%. So T 10% how? 10% completion है ना? So we can say 1 by K, right? ln 10% के लिए 100 upon 90 divided by 1 by K ln 100 upon 90% completion. And yeah, it's a 90% completion. So 90% completion. So 90% completion के लिए we get ln 100 upon 10 because 90% complete. So remaining amount is going to be 100 minus 90. ठीक है, तो 1 by k cancel, so we can solve this. So ln 100 minus ln 90, or what we can say that it can be 2.303 log 10 upon 9, and here 2.303 log 10, है ना, log 10. So 2.303 cancel, so we get log 10 minus log 3 का power 3 upon log 10. तो log 10 is 1, log 10 is 1, so let's solve this. So 1 minus 3 into 0.4771 upon 1. ठीक है, so 1 minus 3, so we can say 3 into 0.4771 and 1 minus answer. So we get answer equal to 0.43. Answer is 0.43. अब क्वेश्चन सेज कि इट इज 25 टाइम्स ना, 25 टाइम्स, 25 टाइम्स, तो 25 टाइम्स तो नहीं आ रहा ना, है ना. क्वेश्चन सेज कि टाइम रिक्वायर्ड फॉर 10% कंप्लीशन इज 25 टाइम्स द टाइम रिक्वायर्ड फॉर 90% कंप्लीशन. तो x का वैल्यू इज नॉट equal to 25. So this statement is also false. Okay. Now let's understand the statement number D. The degree of dissociation is equal to. Fine. So degree of dissociation. How to solve this? So bete dekho. If we have suppose A and B. So suppose it is 1, then 0, then 1 minus alpha, and that is going to be alpha, 1 alpha. ठीक है. So we know that what we know that ki how to solve this. KT is equal to ln initial is 1 and then 1 minus alpha. So KT is equal to ln 1 minus ln 1 minus alpha. So ln 1 minus alpha is equal to minus of KT. So 1 minus alpha is equal to e to the power minus KT, and alpha is equal to 1 plus e to the power minus KT. So that is true. Perfect. So last, the rate and rate constant have the same unit for the first order. So rate unit is what? Mole per liter 1 minus n s minus 1. ठीक है. So if it is the first order reaction, so first order reaction है, तो first order reaction में क्या होगा? 1 minus 1 0, so that is going to be second inverse, right? Second inverse. ठीक है. And what is the unit? एक मिनट. K का unit is this second inverse. एंड रेट तो क्या होगा, मोल पर लीटर पर सेकेंड. सो दिस मतलब दे डू नॉट हैव द सेम यूनिट. सो आंसर इज फॉल्स. ठीक है. सो विच इज द करेक्ट आंसर, डी. सो नंबर ऑफ करेक्ट स्टेटमेंट इज इक्वल टू, it is equal to 1. ठीक है. So you have to report the answer as 1. Okay. Let's do next question. A gives B. So the above reaction is of zero order. Okay. The half life of the reaction is 50 minutes. So for zero order, T half is equal to A naught upon 2K. Fine. So this is 50. So A naught upon 2K. So the time taken for the concentration of A to reduce to 1/4 of its initial value. 1/4 करना है. So we have this one, A naught minus A, it is equal to KT. ठीक है. KT. So from here K का value is what? A naught upon 100. So A naught and this is 1/4. Right, 1/4. So we can say A naught upon 4. K is A naught upon 100 and this is T. So we have to find out the value of this T. So 3 A naught upon 4, which is A naught upon 100 into T. So A naught cancel out. So time is equal to 300 upon 4, which is equal to 75 minutes. So answer is 75 minutes. Okay. Now let's do next question. If compound A reacts with B following first order kinetics and the rate constant is given 2.011 into 10 to the power minus 3 second inverse. So the time taken by A to reduce from 7 gram to 2 gram will be. So how to solve? T is equal to 2.303 upon K log initial concentration upon final concentration. So what we can write, 2.303 upon 2.011 into 10 to the power minus 3 log initial 7 upon some volume, और ये moles होंगे तो volume, तो that is going to be same. So we can even take the mass also, right? We can even take the mass also, like initial mass and then final mass. Because if mass is same, then moles they are same and moles are same, then the concentration is going to be same. So we can say 7 by 2. It's just now you have to solve this. So once you solve it, now when you solve it, so you get time equal to 622.9, but you have to report the answer in nearest integers. So that is equal to 623. So answer 623. Okay. Now let's do next question. A and B are two substances undergoing radioactive decay. अब radioactive decay है, so it means it's a first order reaction. It's a first order reaction. Why? Because it's a radioactive decay. Fine. The half life of A is 15 minutes and that of B is 5 minutes. Okay, so T half A is 15 minutes and T half B is 5 minutes. Fine. So if the initial concentration of B is 4 times, so A naught, suppose X है, so A naught for this one it is 4x, for B it is 4x, and final concentration, they both start decaying at the same time. How much time will it take for the concentration of them, both of them, to be same? It means A is going to be same. Y है, so इधर भी A is equal to Y. ठीक है. So how to solve this? So देखो, simple. We have T1, suppose this is first and that is second. So we can say T1 is equal to 2.303 upon K1 and log x over y. ठीक है. Similarly T2 is equal to 2.303 upon K2 log 4x upon y. ठीक है. So from here we can find out the value of y. So log y is equal to how much? Log x minus T1 K1 upon 2.303. So similarly here log y is equal to what? Log 4x minus T2 K2 upon 2.303. Right? So log y both are same na? Both are same. So what we can say, that we have answer equal to log x upon 4x is equal to T upon 2.303 common, and we have K1 minus K2. And now is just you need to solve. Yeah, you need to solve for T. So solve for T, and you get T equal to 15 minutes. You equal to, matlab you get T equal to 15 minutes. So answer is this. Answer is 15. Okay. Now let's do next question. The reaction 2A plus B2 gives 2AB, and it is an elementary reaction. So for the elementary reaction, so we can take coefficient equal to the order. So we can say K, A to the power 2 and B to the power 1, B2 to the power 1. So that is going to be the rate law expression. So question says, for a certain quantity of reactants, if the volume of the reaction vessel is reduced by a factor of 3, so it means if R1, so I can write K, A2 and B2, and R2 में volume is reduced by 3 ना. So suppose we have same moles. So if we have same moles, so we can say this is K x by V square, and this is Y by V. अब now volume is reduced हुआ but the moles are same, so we can say x by V by 3 square and y by V by 3. So we get equal to what? 3 square and 3 R1, which is equal to 27 times of R1. ठीक है, तो answer is 27. Okay, now let's do next question. Decomposition of X exhibits a rate constant of this. Okay, the rate constant is 0.05 microgram per year. So if you see the unit of rate constant, then it is going to be the zero order reaction. So how many years are required for the decomposition of 5 microgram into 2.5 microgram? It means we have to calculate T half, because the concentration is reduced to half, mass is reduced to half. So T half for zero order reaction is what? A naught upon 2K. So initial 5 and K is 2 into 0.05. So we can say that 5 into 100 upon 10. So on solving this, we get 50 here. So answer is 1. Answer is 1. Now let's do next question. Sucrose hydrolysis in an acid solution into glucose and fructose. ठीक है. First order है. Half life is this. After 9 hours, the fraction of sucrose remaining is F. So we have to find out the value of 1 by F. So देखो, T half is what? 0.693 upon K. So K is going to be 0.693 upon T half, which is 3.33. So now T is equal to 2.303 upon K log initial fraction 1, तो final F है, so that's it. So it means now we have to find out the value of log 1 by F. So how to find out the value of this? So log 1 by F is equal to T. Okay, so T is what? 9 after 9 hours. So 9, K का value 0.693 and this is 2.303 into 3.3. ठीक है, 3.33. So it's just you have to solve this. Once you solve this, so you get log 1 by F 0.8124. But you have to report the answer in 10 to the power minus 2. So we can say 81.24 into 10 to the power minus 2. So answer is going to be 81. Clear? So answer is going to be 81. Let's do next question. So at 373 Kelvin, a gaseous reaction A gives 2B plus C is found to be first order reaction. Fine. A gives 2B plus C, first order. Starting with pure A, the total pressure at the end of 10 minutes, it was 176. Fine. So T is equal to 0 पे we have P pressure and T is equal to after 10 minutes. So we have P minus P naught, and this is going to be 2P naught, and that is P naught. So P minus P naught plus 2P naught plus P naught, it is equal to 176, right? We get 176. So P plus 2P naught, it is 176. ठीक है, 176. Okay, fine. ठीक है. And after a long time, when A was completely dissociated, यानी T is equal to infinity, So we have 2p and p, right? 2p and p. It means A completely dissociated into B and C. So we can write 2p plus p, and we have 270 mm of Hg. We are not going to write p naught, right? So it means we can write 2p plus p, it is equal to 270, where p ka value is going to be 270 upon 3, 90 mm of Hg. Okay. So the pressure of A at the end of 10 minutes was, it means we have to calculate the value of P minus P naught. P minus P naught. So first, though, we know that P plus 2 P naught is equal to 176. P naught value we have to find. So P ka value is 90. So 90 plus 2 P naught is equal to 176. From that, P naught ka value comes out to be 43. Now we have to find out P minus P naught. This is the pressure after 10 minutes. Pressure of A after 10 minutes. So P is what? 90, and that is 43. So 90 minus 43 is going to be 47 mm of Hg. Okay. So answer is option number B. Okay. Now let's do next question. N2O5 decomposes into NO2 and O2. So basically 2, 4. Fine. After 50 minutes, the pressure inside the vessel increases from 50 mm of Hg to 87.5 mm of Hg. So yani T is equal to 0 pe we have 50 mm. So starting 0, so T is equal to, after 50 minutes, it is 50 minus P naught. We can write 2 P naught. So this is 4 P naught and this is P naught. But I'm going to write with respect to this 50 minus P naught. So this is 2 P naught and this is P naught by 2. So after 50 minutes, it is reduced now. So we get 50 minus P naught plus 2 P naught plus P naught by 2. That is equal to 87.5. Fine. So let's solve this. So we get 50 plus 3 P naught by 2 is equal to 87.5, right? So value of P naught comes out to be 25. Value of P naught from here comes out to be 25. Fine. So if P naught is 25, so 50 minus 25 is what? 25. So see, pressure is reduced to half. Pressure is reduced to half, right? So T half is actually equal to 50 minutes, which is equal to 0.693 upon K, and we can find out the value of K, 0.693 upon 50. Up now, next question. The pressure of the gaseous mixture after 100 minutes, So how to solve this? K is equal to 2.303 upon T log initial 50 and final suppose X, final, or we can say something called 50 minus P naught dash. Okay. So K value is 0.693 upon 50, 2.303 upon 100, and log 50 minus P naught dash. Okay. So once we solve for this, so we get 50 minus P naught dash, it is equal to something 1 point, not 1.25, 12.5. So P naught dash is equal to 50 minus 12.5, which is 37.5. ठीक है, 37.5. Fine. अब now in order to find out the total pressure, है ना, total pressure निकालना है. So total pressure is going to be what? 50 minus P naught dash plus 2 P naught dash plus P naught dash upon 2 after 100 minutes, right? So that is going to be कितना? It means 50 plus 3 P naught dash upon 2. So when you solve this now completely, you have to put the value of P naught as 37.5. So when you put the value of P naught as 37.5, so you get answer, yani P total equal to 106.25, right? 106.25. Okay. Now we are moving to the next problem type, and in this we are going to discuss questions related to Arrhenius equations. Arrhenius equation. Okay. So what is Arrhenius equation? Arrhenius equation is this: K A e to the power minus Ea over RT, where K is going to be the rate constant, Ea is the activation energy, T is the temperature, and R is the gas constant. Okay, so we can write this equation in terms of this: ln K is equal to ln A minus Ea over RT. We can also write the same equation with respect to this: log K is equal to log A minus Ea over 2.303 RT. So if we have a particular kind of reaction and we have different rate constants for that, then we can also write, we can also use this equation in order to solve the question. Now let's do question number 1. Consider the given plots for a reaction obeying Arrhenius equation. 0 degree Celsius, temperature 300. K and A are rate constant and activation energy. Okay, so first plot is going to be in K versus EA. So K is what? AE minus EA over RT. So what we can write: K A E minus EA, or E 1 upon RT, right? So this is Y and this is e to the power minus x. Rest part is the constant, right? Rest part is the constant, it doesn't matter. So the curve of this is going to be decreasing curve, na? So it is going to be this. So K versus EA curve. So yes, so it means this curve is true. Now similarly, if I want to plot a curve in between rate constant and temperature, so that is equal to K A E minus EA over RT. So what we can write: K A E minus EA over R minus EA over R, 8 minute, minus EA over R, और what we can say, E की power T हो जाएगा. That is going to be E की power T, or see what we can also write in that way ना, कि EA over R or e की power minus 1 by t, so which we can write as K A EA over R and e to the power t. So here y and that is x, so it means exponential increasing curve, so we get this curve. ठीक है, so K versus T curve is this, temperature curve is this, T temperature. ठीक है, so it means this is also true. So what we can say that both 1 and 2 are correct. So option B is going to be the correct answer. Okay. Now let's do next question. If a reaction follows the Arrhenius equation, the plot of ln K versus RT. So bete K is equal to AE minus EA over RT. So we have ln K is equal to ln A plus ln E minus EA over RT. So we can write ln K is equal to ln A minus EA over RT ln E. Okay. So ln K versus 1 by RT. So the gradient gives the value of minus y. So it means if I plot curve ln A K and 1 upon RT, so we get a negative slope na, like this. So the gradient gives the value of minus y. So it means what we can say that minus EA is equal to minus y. So EA value is going to be y units. Okay, that is basically slope. ठीक है ना? We have to compare this equation with y is equal to c and this is plus mx. So x is what? RT, 1 by RT. Clarity, that's it. So answer is 2. Option 2 is the correct answer. Now let's move to the next question. So two reactions R1 and R2 have identical pre-exponential factors. It means A1 is equal to A2. Activation energy of R1 exceeds that of R2 by 10 kilojoule per mole. It means EA1 is equal to EA2 plus 10,000. If K1 and K2 are rate constant for reaction R1 and R2 respectively at 300 Kelvin, the temperature is 300 Kelvin. So we have to find out ln K2 by K1. So temperature is also constant, right? So what we can say that K2 upon K1, so that is A2 E minus EA1 upon RT upon A2 or T1 A1 E minus EA2 upon RT2. So T1 is equal to T2, A1 is equal to A2. So it means we can write K2 upon K1. It is A upon A. E minus EA1 upon EA2 bit. EA2 and here we write EA1. A net T2 and T1. Okay? So minus EA2 upon RT2 RT and E minus EA upon 1 RT. So AA cancel out. So K2 by K1 it is okay. How can we write E 1 by RT common? So we can write minus EA2 plus EA1. Okay? So let's put the value E1 by RT. EA2 is this and EA1 exceeds EA2 by 10,000. Okay? So what do we get? We get E to the power 10,000 RT. Okay, beta? Now we have to find out the value of ln K2 by K1. So ln K2 by K1 it is equal to 10,000 RT ln E. So it means 10,000 upon 8.314 into temperature 300 na. So we have to solve this one. So when we solve this one, we get answer equal to 4. So answer is 4. Okay. Now let's do next question. For the reaction AA plus BB, it gives C the plot of log K versus T 1 by T. So log K is equal to what? Log A minus EA upon 2.303 RT log E. Log, right? तो log 10 हो जाएगा ना वो basically. So that is going to be what? So we have this equation. Fine. So log K upon 1 by T slope is equal to this. So we can say that minus EA upon 2.303 R it is equal to 10,000. Okay, that's it. Now the temperature at which rate constant of the reaction is itna. Suppose this is K2. So we have to find out T2. And rate constant of this reaction K1 is itna at temperature 500 Kelvin. So which formula we are going to use? We are going to use this formula na log K2 upon K1 it is equal to EA upon 2.303 R upon 1 by T1 minus 1 by T2. Now we have to put all the values. So K2 minus 4, K1 10 to the power minus 5, EA upon 2.303 R. EA upon 2.303 R 10,000. 10,000. 1 by T1 500. And T2 we have to find out. So we have to solve. So that is log 10, 10,000 and then 1 by 500 minus 1 by T2. So log 10 is 1. So 10,000 1 by 500 minus 1 by T2 is just now you have to solve everything. To solve for T2. So when you solve for T2, so T2 comes out to be 526 Kelvin. ठीक है 526 Kelvin. So answer is 526. ठीक है 526. Now we are moving to the next slide. So activation energy. So here we are going to use the Arrhenius equation in order to calculate the activation energy. But here we can calculate activation energy for different types of reactions, right? So let's discuss some of the formulas over here. So first we are going to discuss some graph related question over here. So if I'm going to draw the curve, right, with respect to energy and reaction coordinate, so we can get this kind of curve. So as you can see over here, so here energy of product is less than the energy of reactant. So if energy of product is less than the energy of the reactant, then the delta H is going to be what? Negative. Delta H is going to be negative. So it means this curve is for exothermic reaction. This curve is for exothermic reaction. So up now here we have some terms, right? So from origin to the total energy, right? Total. So here this is the energy of activated complex, right? So this is the energy of activated complex. ठीक है? That is the energy of reactant and that is the energy of the product. So from 0 to the energy of activated complex, we have the threshold energy, right? We have threshold energy. Now from energy of reactant to the activated complex energy, that is equal to the activation energy. And the difference in between energy of product and reactant, that is equal to the enthalpy. So when we talk about the reactants, so what happens? Suppose we have AB and B, or we can say we have suppose AB and B2, right? AB and B2. So या फिर we can say we have AB plus B. ठीक है? तो first what will happen if I want to form this product? We formed A plus B2. So what happens? The bond present in between A and B, it is going to dissociate and we have new bond formation in between B. Right? So this is activated complex. This is activated complex. Okay. A plus B2, that is product, and AB plus B, that is reactant. ठीक है? That's it. Now we have, suppose if we have the equilibrium reaction, तो equilibrium reaction है तो KF and KB है, so we have to define KF like AF E minus E activation energy for forward reaction. So EAF is what? Activation energy for forward reaction. Activation energy for forward reaction, right? So similarly, EAB is the activation energy for backward reaction. So I'm going to apply Arrhenius equation over here. So we can say ln Kf upon Kb is equal to ln Af upon Ab minus delta H over RT, where delta H is activation energy of forward reaction minus activation energy of backward reaction. So we are going to use these formulas over here. So let's solve question number 1. So question number 1 says for the adsorption of hydrogen on platinum, so hydrogen on platinum, so activation energy, suppose I am taking as EA1, that is 30 kilojoule per mole. Okay, and hydrogen on nickel, so activation energy, it is equal to 41.4 kilojoule per mole. ठीक है? So the logarithm of the ratio of the chemisorption on equal rates of metal at 300 Kelvin. So temperature is 300 Kelvin. So we know that rate is directly proportional to K, rate constant. So for this I can write K1, and for EA2 wala, for hydrogen or nickel, I can write K2. ठीक है? So K2 is what? AE minus EA2. यही तो होगा ना? KAE minus, मतलब whatever, मतलब it's the, that's a simple thing, you can write anything over here, right? So what I am going to do, if I say 41 का R2 कर देंगे ना, तो फाइन, तो K2 is equal to minus EA2 upon RT. ठीक है? We have to find out the value of what? Logarithm, log का निकालना है, we have to find out this value. So K1 is equal to AE minus EA1 upon RT. Okay, we have to find this one. ठीक है? Okay, that's 30 kilojoule and that's 41.4 kilojoule. So let's put all the values. So K2 is equal to AE minus 41.4 EA upon R into T, that is 300, which we can write as K2 is equal to AE. On solving this further, we get minus 138 upon R. Similarly, K1 is equal to AE minus 30 किलोजूल है ना, 30 किलोजूल है. अच्छा यहाँ पे ना किलोजूल है तो we have to write 1000. So on solving this we get this one. So here 30 kilojoule यानी 30 into 1000 upon R into 300. So on solving this, what do we get? We get K1 is equal to AE minus कितना आ जाएगा 100 upon R. ठीक है 100 upon R. So now what we are going to do? We are going to find out the difference. So we can say log K2 upon K1 we have to find out, or what we can do, log K2 minus K1. So on solving this, what do we get? Log A minus 138 upon 2.3 R, ठीक है, minus log A then minus 100 upon 2.3 R, ठीक है 2.3 R. तो how to solve this? So we get log K2 upon K1. So log A cancel out. So we get minus 138 upon 2.3 R plus 100 upon 2.3 R. ठीक है, clarity. So we can find out the value of this one. So on solving this, we get around 1.98 something, or which we can round it off to 2. Clarity. So that's it. That's it, right? So we get the answer equal to minus now, but obviously we have to take the mode of this one. Okay, mode of this one. So answer is 2. So we have to report answer as 2. Clear? Now let's do next question. So consider the following reaction that goes 2 in 3 steps as shown below. So see, energy. This energy is the energy of intermediate. So this blue one is the intermediate. ठीक है? So if we have 2 intermediates ना, then how many transition state? 3 transition state. ठीक है? So transition state, they are going to be intermediate plus 1. So it means transition state 2 plus 1 3. ठीक है? So number of intermediates 2, number of activated complex which is transition state. So activated complex 3, and rate determining step. So rate determining step, highest activation energy, because if we have highest activation energy, so that is going to be the slowest reaction. If that is going to be the slowest reaction, so that is the rate determining step. So here activation energy is highest, here EA is highest. So second step is the rate determining step. So on the basis of that, we get option number 3 as the correct answer. Okay. Now let's do next question. The number of given statement which is our correct is. So first statement is, the stronger the temperature dependence of the rate constant, the higher is the activation energy. So stronger the temperature dependence of rate constant means कि small change in temperature results in more rate, or we can say we can have more rate change, or we can say rate of reaction increases, right? So if we have more activation energy, then rate constant decreases. Why? Because K is equal to AE minus EA over RT. So if activation energy value increases, then E ka power is going to be more negative, and if E to the power it becomes more negative, so overall this term it becomes less. So if it becomes less, so K decreases. ठीक है? अब now rate constant is less. अब the point is that if the rate constant is less, now you increase temperature. So small change in temperature results in more effective collision, or we can say now rate increases. And if rate increases, then K2 value also increases, right? So for this part, we can also have this temperature coefficient mu, which is the ratio of the rate constant at two different temperatures. So KT plus 10 upon KT. Okay? So that is the temperature coefficient. So this statement is true, right? Next, If a reaction has zero activation energy, its rate is independent of temperature. So zero activation energy, so it means Ka to the power minus 0 over RT. So it means K is a, so it is independent of temperature. So this is also true. Next, the stronger the temperature dependence of rate constant, smaller is the activation energy. It contradicts with the first statement. So this is false. Next, if there is no correlation between the temperature and the rate constant, means rate constant is independent on temperature, then it means it has negative activation energy. No, a negative activation is a separate concept, right? So that cannot be true. So this is false. So number of given statements which are correct, the answer is 2. Okay. Now on the basis of same thing, let's do next question. The number of correct statement from the following. Larger the activation energy, smaller is the value of rate constant. Rate constant. In the above question, I have proved this. So this is true. Higher is the activation energy, higher is the value of temperature coefficient. Yes. What temperature coefficient? Kt plus 10 upon Kt. So it means if we have more activation energy, so K value is less. So very small change in temperature results in more what? More K, yani more K results in more new rate constant. So if we have more rate constant, so the temperature coefficient is also more. So this is true. At lower temperature, increase in temperature causes more change in the value of K. Yes, due to more effective collision, we can say. Now D, a plot of ln K versus T. So K is what? A E minus EA over RT bete. So ln K is equal to ln A minus EA over RT ln E. So now we have to compare this equation with y is equal to mx plus c. So yes, the slope is equal to minus EA over R. Okay, so that is also true. So number of correct statement from the following, that is equal to 4. Okay. Now let's do next question. The rate constant of the above reaction at 200 Kelvin and 300 Kelvin are 0.03 and 0.05 per minute respectively. Okay, fine. So T1 200 Kelvin, T2 300 Kelvin. So K1 is 0.03, K2 is 0.05. So the activation energy of the reaction. So which formula we are going to use? We are going to use log K2 by K1 is equal to EA upon 2.303 R 1 by T1 minus 1 by T2. Now you have all the values. You can put the value and find out the value of activation energy. So once you solve this, you get answer equal to 2520 Joule. That is the answer that you will get. Okay. Now let's do next question. Consider the given plot of enthalpy of the following reaction, right, between A and B. A plus B, it gives C plus D, and identify the incorrect statement. So we have what? A plus B, C plus D. Okay, we have this. Fine. So, incorrect statement. Formation of A and B from C has highest enthalpy of activation. So, A and B from C. So, activation energy is this. So, here activation energy A and B from C basically. So from C to activation energy is this. So from C to this. So yes, that is 20 kilojoule. Okay. So that is going to be the highest. This is the true statement. Now activation enthalpy to form C is 5 kilojoule per mole less than to form D. Okay. So if you form C from A to B, so activation energy is this. Activation energy is this, which is equal to A to B to C. So activation energy is equal to 20 minus 5, 15. And if you form A to D from A to B, so activation energy is itna 15 minus 5, that is 10. So it is not less, it is more. So that statement is false. That statement is false. Clear? That statement is false. Now let's understand third one. D is kinetically stable product. Kinetically stable product means which is faster, matlab the reaction should be faster, and for the faster reaction activation energy should be least. So activation energy should be least. So yes, activation energy is least. A to B, activation energy is least, so this is true. C is thermodynamic stable product. Yes, this is also true because C energy is least. Energy of C is least. So which is the incorrect statement? Option 2 is the incorrect statement. Clear? Okay. Now let's do next question. The following mechanism has been proposed for the exothermic catalyzed complex reaction. So A plus B, it is the fast. So if it is the fast, so activation energy is very less. K1 है and then K2 है. And it says K1 is much smaller than K2. So if K1 is much smaller than K2, yani activation energy is more. And here activation energy is less. Exothermic means energy of product. Exothermic means energy of product is less than the energy of reactant. So let's see. So if activation energy is less, so देखो A plus B to this. So here activation energy is ना least है. ठीक है. Then IAB to AB. So activation energy is more. इतना. Then here activation energy is itna, हाँ, this much. So yeah, this is the correct curve, right? This is the correct curve. Clarity. So, अच्छा, this why this cannot be true? Why this cannot be true? So देखो, it is slow, it is more, right? It is more, but here activation energy is too much. So it means here K2, K2 is going to be smaller than K1, than K1. So that's where our option, मतलब answer is option number A. ठीक है? That's it. Now next. For the equilibrium A gas, it gives B gas, delta H is itna, minus 40 kilojoule per mole, and the ratio of activation energy for forward and backward reaction, that is equal to 2 by 3. Perfect. So what is delta H? So delta H is activation energy of forward reaction minus activation energy of backward reaction. So this is minus 40. So activation energy of forward reaction I can write as 2 by 3 activation energy of backward reaction minus EAB. So on solving this, we get activation energy of backward reaction as 3 into 40, which is 120 kilojoule. ठीक है? So we have one option with respect to this. So answer C is the correct option, but you can also find out the activation energy of forward reaction. So activation energy of forward reaction is 2 by 3 into 120, and on solving you get 80 kilojoule per mole as the answer. So option 3 is the correct answer. Okay. Now let's do next question. An exothermic reaction X to Y has an activation energy 30 kilojoule per mole. Okay, activation energy 30 kilojoule, yani forward reaction, it is 30 kilojoule per mole. If energy change during the reaction, delta E minus 20 kilojoule, then the activation energy for the backward reactions. So which formula we are going to use over here? Delta E is equal to EA forward minus EA backward. So minus 20 is equal to 30 minus EA backward, and E activation energy for backward reaction is 30 plus 20, which is equal to 50 kilojoule per mole. So answer is 50. ठीक है? So that's it for the activation energy. We have discussed enough questions which are related to curves and all. Now we are moving to the next problem type, and in this we are going to discuss some problems which are related to the catalyst. Okay. So in presence of catalyst, what happens? Rate of reaction increases. So we have two kinds of catalyst now. One is positive catalyst, second is the negative catalyst. So in the presence of positive catalyst, rate of reaction increases, while in the presence of negative catalyst, rate of reaction decreases. So in the presence of positive catalyst, activation energy decreases, due to which rate of reaction increases. And vice versa is true for negative one. So here activation energy increases. Suppose this is the uncatalyzed reaction. This is what? Uncatalyzed catalyzed reaction. So for uncatalyzed reaction, activation energy is this much, reactant energy to the activated complex energy. Now in the presence of positive catalyst, what happens? Activation energy decreases. Okay, but enthalpy is going to be same, delta H is going to be same, it's just activation energy decreases. So it means EA catalyzed and this is going to be EA uncatalyzed. Okay, so that is in the presence of catalyst. Here delta H is going to be same only. Okay, so let's discuss the question of this type. So how to discuss the question of this type? So see, the correct reaction profile diagram for a positive catalyst reaction is. So positive catalyst activation energy should decrease. So here activation energy decreases, here activation energy decreases. Right, so we have option number 3 and 4. Now if you see option number 4, so we have difference in delta H. Delta H difference is there. Right, delta H difference is there, but if you see the option number 3, delta H is same, so it means the answer is option number 3. Okay, now let's do next question. For a reversible reaction A to B, okay, A to B hai, delta H for forward reaction, it is 20 kilojoule per mole. Fine, so it means delta H of the reaction is 20 kilojoule per mole. The activation energy of uncatalyzed, yani activation energy uncatalyzed without catalyst, right? It is 300 kilojoule per mole, and that is for forward reaction. Forward reaction. Question says when the reaction is catalyzed, keeping the reactant concentration same, the rate of the catalyzed forward reaction at 27 degree Celsius is found to be same as that of uncatalyzed reaction at 327 degrees Celsius. It means here temperature is 327, so 327 plus 273, which is equal to 600 Kelvin. Now we have activation energy for the catalyzed, right? Forward reaction. Okay, forward reaction we have to find out, but here temperature is what, 27 plus 273, which is equal to 300 Kelvin. Right, when the reaction is catalyzed, keeping the reactant concentration same, the rate of the catalyzed forward reaction at 27 degrees Celsius is found to same, yani rate is same, rate is same. So if rate is same, so what we can write, rate is same, it means K is same. So we have this formula, K is equal to AE minus EA over RT. So what we can write? Minus EA upon RT, that is equal to constant. Okay. So we can apply this formula for catalyzed and uncatalyzed reaction. So this is minus EA without catalyst, forward reaction upon RT. Suppose it is RT1, and here minus EA catalyst presence में forward reaction upon RT2. So this is we have to find out what E activation energy of catalyzed for forward reaction. So RR cancel, which is EA or activation energy without catalyst forward reaction into T2 upon T1. ठीक है? So T2 300, T1 600. So let's just put the value. So on putting the value, we get activation energy for catalyzed forward reaction. It is equal to 300 into 600 upon 600. Right? नहीं, गलत कर दिया. Activation energy is 300. T2 is 300. Yeah, that is 300 divided by 600. So on solving this, what do we get? We get 150 kilojoule. Up now in the question, what do we need to find out? We need to find out activation energy of catalyzed backward reaction. So for that, we are going to take help from the delta H. So delta H is what? Activation energy for forward reaction minus activation energy for backward, but that is for catalyzed. So we have to find out EAB. So EAB is EAF minus delta H. So EAF is 150 and delta H value is 20. So we get answer equal to 130. So delta H is equal to 130. 130 है ना, 150 है. Okay, 150 minus 20, so 130. That's it. Okay, now let's do this question. Consider the following plots of rate constant versus 1 by t. So K is equal to AE minus EA over RT. So log K is equal to log A minus EA upon 2.303 RT log E, log 10 basically. ठीक है. अब now what to do over here? What to do over here? Okay. So log K y is equal to mx and plus c. तो slope is negative. Slope is negative. And slope का value is minus EA upon 2.303 R. Okay. So which one has more activation energy? The one which has more negative slope. So if you see the curve carefully, which one has more negative slope? So negative slope order. So that is C, then A, then D, and then B. देखो C का सबसे ज़्यादा है. Then A, then D, and then B. So it means activation energy is going to be in the order of EC, EA, ED, and EB. So answer 3 is the correct answer. Okay. Now let's do next question. The rate of a certain biochemical reaction at physiological temperature occurs 10 to the power 6 times faster. So it means R2 is equal to 10 to the power 6 R1. So we can say that K2 is equal to 10 to the power 6 K1. With enzyme than without. Okay, so the change in activation energy upon adding enzyme is. So basically what we are going to do, so see, K is equal to AE minus EA over RT ना, ठीक है. तो what we can say that कि log K2 over K1 है and I am writing minus delta EA upon RT, ये लिख रही हूँ मैं, ठीक है. प्लस log A भी है, we have something, right? So A is same, ठीक है. A is same, K2 and K1 different value है, right? तो log K2 by K1 कितना हो जाएगा? That is going to be log 10 to the power 6, so minus delta EA upon RT. So delta EA means catalyzed and without catalyzed. It means we are saying कि catalyzed and without catalyzed, ठीक है? That difference. So change in activation energy, ठीक है? So what to write? So we get answer equal to 6. अच्छा यहाँ पे 2.303 भी आएगा ना, log 10, ठीक है. So 6 minus 6 into 2.303 RT, that is going to be the activation energy or difference in activation energy. That is activation energy in the presence of catalyst minus activation energy in the presence of or in the absence of catalyst, without catalyst. Okay. So we can directly relate this. So answer is going to be 1. ठीक है, that's it. Now let's do next type of question. The variation of the rate of an enzyme catalyzed reaction. So enzyme catalyzed reaction and the curve is in between rate of reaction and substrate concentration. So how to solve? First, so you should know the derivation for that. So see, E plus S, right? So that's a equilibrium process, K1 minus K1. So we get ES and then K2 say we get E plus P. So rate of the reaction is K2 concentration of ES. So ES is basically the enzyme substrate complex. Enzyme substrate complex. So it means we have to change the concentration of ES in terms of E and S. Here E naught co I am taking as total enzyme concentration. So total enzyme concentration is some enzyme is going to be in free, it is going to exist in free form and some enzyme is going to exist in the form of complex. So from here we can say that E is equal to E naught minus ES, ठीक है. E is equal to E naught minus ES. So अब see how to solve this question. Here we have to apply steady state approximation. So steady state approximation means small change in the enzyme concentration with respect to time, right? With respect to time, we have to consider this as 0. If I am going to consider this as 0, right? If I'm going to consider this as 0, so what to do over here? So dEs over dt. So Es ko how do we write? This is K1 concentration of E and concentration of S minus K1 के लिए ES concentration decreases, so minus K minus 1 ES. Let me rewrite this, right? Let me rewrite this. So basically dEs over dt, it is equal to 0. So we can write K1 concentration of E and S. That is for this reaction. Forward reaction, because in the forward reaction enzyme substrate concentration decreases. Now for the backward reaction enzyme substrate complex concentration decreases, so we write minus K minus 1 ES. Then in this reaction enzyme substrate concentration decreases, so we can say minus K2 ES. Okay, now let's put value of E over here. So E ka value is what? E naught minus ES. So let's put this. So we get 0 K1 E naught minus ES, then S minus K minus 1 ES minus K2 ES. ठीक है, which we can write as K1 E naught S minus ES K1 ES S minus K minus 1 ES minus K2 ES. Okay, so what we can write? We can write ki ES concentration is equal to K1 E naught S upon K1S minus, plus K minus 1 plus K2. Right, now let's divide everything by K1. So if I'm going to divide everything by K1, or let's put the ES का concentration into rate 1. So what is the rate? K2 ES है ना? Rate is K2 ES. So K2 ES. So we can write K2 K1 E naught S upon K1 S plus K minus 1 plus K2. ठीक है? That's it. अब now what I'm going to do? I'm going to divide numerator and denominator by or multiply this by K1. Divide करना. Divide numerator and denominator by K1. So if I do this, so we get rate is equal to K2 E naught S upon S and K minus 1 plus K2 upon K1. So this is called Km, Michaelis-Menten constant. So here R is equal to K2 E naught S and Km plus S. This is what? Km is what? Michaelis-Menten constant. Up now in this we are going to put some assumptions. What I am going to say is, suppose at high concentration of enzyme, if we have high concentration of enzyme, so if we have high concentration of enzyme, then what happens? E naught concentration is equal to Es, because now enzyme forms activated complex, right? Enzyme substrate complex, which can further convert into the product. So if I do so, so rate is going to be the R max, है ना? So if rate is going to be R max, so I can write this as R max, ठीक है? R max, और एक मिनट, let me write. We can write R max is equal to V max. It is equal to, if E naught is ES, है ना? If E naught is ES, so we can say that rate is equal to K2 E naught, है ना? K2 E naught. Otherwise, before rate it was K2 ES, है ना? Initial rate is K2 ES. But now at higher concentration we have R max is equal to this one. So in place of K2 E naught I can put R max. So here we can write R is equal to R max S upon Km plus S, right? So if substrate concentration is too much, very more, so what we can say, R is equal to R max S upon S, or R is equal to R max. It means if the substrate concentration is too much, then the rate is going to independent on the concentration. So if I see this kind of curve, so which is going to be the correct? Which is going to be the correct? So see, option C is the correct, because देखो, on high concentration what happens? Rate of reaction is independent on to the concentration of substrate. Is it clear? So there is no need to derive the formula. Ultimately you have to learn this part, but just do it for your reference, right? Just do it for your reference, then you can easily understand the thing. ठीक है, that's it. Enzyme part is over, or catalyst part is over. Now we are moving to the next problem type, which is related to the collision theory. So in the collision theory, what happens ki we have some reactant molecules, they collide with each other, and when they collide with each other, so we have two barriers. One is the energy barrier and second is the orientation barrier. So those molecules which can pass the energy barrier and the orientation barrier, then they are converted into the product. So on the basis of that, we are going to do some questions. So first let's discuss some graph, or one graph related to this. So suppose if we have fraction of molecules, right? Fraction of molecules which passes the energy barrier or the orientation barrier, then they can convert into the product. So I'm plotting the graph in between fraction of molecules and the kinetic energy. Okay, so what happens, suppose at T1 we have this curve is this at T1 temperature, right? So when you increase the temperature na, so what happens ki molecules which can pass the energy barrier is more due to the increase in the kinetic energy. So that's why what happens, we have more molecules which can pass the energy barrier. So suppose I'm saying that T2 is greater than T1, and this is the activation energy EA, this is the activation energy. So at T1 we have only these molecules which passes the energy barrier, right? We have this molecule which passes the energy barrier. Let me plot a graph again, right? Because that is not visible to you. Let me plot this again. So I'm saying कि suppose at T1 we have this. ठीक है? This is T1. Now at T2 I am plotting a curve like this. ठीक है? So this is T2. Suppose this is the activation energy. Then what happens? If T2 is greater than T1, then more number of molecules can pass through the energy barrier. So when temperature is T1, less temperature, so we have this molecule now which can pass the activation energy barrier, right? Up now, on increasing the temperature, now we have extra addition of the molecules. So these are the extra molecules, right? Extra molecule which passes the energy barrier. Okay. So fraction of molecules which can pass the energy barrier, so that is equal to E minus EA over RT. That is the fraction of molecules having activation energy greater than kinetic energy. So from this we can find out the fraction of molecules from this part. E is equal to minus EA over RT. So now let's discuss question 1. So a bacterial infection in an internal wound grows as this. We have this relation. N dash T is equal to N naught e to the power T, where the time is in hours. A dose of antibiotic taken orally needs 1 hour to reach the wound. Once it reaches there, the bacterial population goes down as this. What will be the plot of this versus time after 1 hour? So if the time is 1 hour, right, so we can say N naught E. It is going to be N naught E, right? So we have this one dN upon dt is equal to minus 5 n square. So what we are going to do? dN upon n square integration and minus 5 dt, and we have to integrate. 0 to t, and here we can say n dash, n dash, and n. So on solving this, once you integrate this, so what do you get? What do you get? You get 1 by n minus 1 by n dash, which is equal to 5t. ठीक है, 5t minus 1 भी कह सकते हैं, 0 to इधर 1 to t कर देते हैं, राइट, वी हैव टू राइट 1 to t. ठीक है, सो 5t minus 1. ठीक है, 5t minus 1. So when the time is 1 hour, तो we can say n dash is equal to n naught e. So we can write 1 by n minus 1 by n naught e is equal to 5, right? 5t minus 1. Now multiply this equation with n naught. So we get n naught by n minus 1 by e, which is equal to 5 n naught t minus 5 n naught. ठीक है, 5 n naught. Now let's plot a curve. Now we have to compare this equation with y is equal to mx plus c. So we get n naught upon n is equal to 5 n naught t minus 5 n naught plus 1 by e, right? So this is y, this is mx, and that is the intercept. So if we compare this with straight line equation, the slope is positive. So we get option number 3 as the answer, right? Option number 3 as the answer. Clear? That's it. Now let's do this question. The number of molecules with energy greater than threshold energy for a reaction increases 5-fold. So if number of molecules increases, so we can say that ki bhai K2 is equal to 5 times of K1. Right, we can also say this. So 5-fold by a rise of temperature from temperature 27 plus 273, it means 300 Kelvin, to 42 plus 273, so 42 plus 273 is 315 Kelvin. ठीक है, so it's energy of activation. So we can use this formula only. Log K2 by K1 is equal to EA upon 2.303 R, 1 by T1 minus 1 by T2. So you have all the values given. Now you can find out the value of activation energy, and once you find out the value of activation energy, the answer is 84297.47. ठीक है, that is in joule per mole. So you can solve on your own. ठीक है, now let's do next question. If the activation energy of a reaction is itna, activation energy is 80.9 kilojoule per mole. Now the fraction of molecules at 700 Kelvin having enough energy to react to form product is E minus X. So fraction of molecules E to the power minus EA over RT. So that is equal to E to the power minus X. On comparison, what is the value? E minus EA over RT is equal to minus X. So it means X value is going to be EA value 80.9, but kilojoule hai, right? So it means into 10 to the power 3. R is 8.31 and temperature is 7. So on solving this, you get the answer. So X ka value, it comes out to be 13.9, which you can report as 40. Which you can report as 40. Okay? So that's it. We have completed the different set of questions related to chemical kinetics. Okay? I hope you understood all the questions. So we have discussed enough questions which will give you enough clarity about the concepts. Rest you have to solve on your own, right? So if you need any other guidance, if you need further guidance, so you can write down in the comment section, and you can also join the PracBee Revision Program, which is the 10-week program, and the description of that 10-week program is in the description box, so you can find all the details over here. If you want to join the PracBee Revision Program, then you can also comment, right? Then we will connect you after that. So now I will see you in the next video, and in the next video we are going to discuss some questions of the atomic structure. Okay, till then, bye, take care.